Okay, so in example 3, we've got two complex numbers and we need to subtract them. And we're going to just think about how to represent subtraction on the Argand diagram. So let's plot these complex numbers on the Argand diagram. So we've got the real axis and the imaginary axis. And we've got this first complex number with real part 2 and imaginary part 5. So let's plot that on. 2 and imaginary parts 5. So that's our complex number Z1. And Z2 has real part 4 and imaginary part 2. So let's go to 4 on the real axis and 2 on the imaginary axis. And that point there represents our complex number Z2. So let's work out what Z1 minus Z2 is, just using this representation of the complex numbers, this form here. So we're going to do 2 plus 5i. You don't need to put 2 plus 5i, but I'm just putting it in a bracket to show that that's the complex number Z. And then subtract, this one we do need to put in a bracket, 4 plus 2i. So we just expand the bracket and then collect together the real parts. We've got 2 minus 4, which is minus 2, and 5i minus 2i, which is plus 3i. So that's one way of subtracting the complex numbers. We're actually going to think about them in this example using vectors. So often it's useful to think about them as vectors. So we're going to think about the position vector from the origin to Z1. And I'm going to denote that by Z1 underlined because we often underline a vector to show that it's a vector. So I'm going to distinguish the complex number Z1, the point, with the position vector by underlining the position vector. And then I'm going to think of this position vector as Z2. So what we want to do is we want to do the vector Z1 plus Z2, the vector Z2. So that's going to be 2, 5, sorry, we're subtracting them, 2, 5, and then minus the vector for Z2. The vector for Z2 is 4, 2. And you can see that we're going to do the same calculation. We're going to do 2, here we did 2 take away 4, here we're going to do 2 take away 4 to get the real part, which is 2. And to get the imaginary part, we're going to do 5 take away 2, which is 3. So we get the same answer. Sorry, that should be minus 2. Okay, and this vector here represents the position vector of this complex number. So the answer is minus 2, real part, and the imaginary part is 3. So let's sketch that on. Minus 2 and 3 on the vertical axis. So we've got that there. So that's our complex number, which is minus 2 plus 3i. And again, we could represent that using a position vector. So this vector here is Z1 minus Z2. That's our vector. And remember the interpretation of vectors. This is the vector that starts at the end of Z2 and takes us to the end of Z1, provided that the vectors are position vectors. So basically that's this vector here. So that's the vector Z1 minus Z2. So that's a really useful fact that we're going to use quite a lot later on. You can find the vector that goes in between 2 points on the Argand diagram using just what you would normally do with vectors by subtracting them.